You don't have any.
Oh, weird. Huh? Oh, this is ridiculous.
So, hello everyone. I'm not starting the session. Maybe you want.
Hello, everyone. My name is Anna Klameros-Ivan. We start the session called Methodologies in Ecohydrology and in Natural Environment. And we have 6 presentations, so we can start with presentation of Anneline.
Anneli?
Anneli.
Anneli. Yeah. Hello everyone. I'm Anneli. Anneli Säure. And I work at the Julius Kühn Institute in Braunschweig. It's a federal research center for cultivated plants. And I'm going to talk about soil sealing and what kind of soil is lost in Germany. So, as you already know, we talked about this today a lot. There's social sustainable development goals of the United Nations. In Germany, we lose about 45 hectares a day to soil sealing from 2017 to 2020. It's like a mean. And if the soils are sealed, the soil functions are damaged partly or completely. And of course, this is not a German problem. It's a nationwide, it's a worldwide problem. And this is why we have the Sustainable Development Goals. Number 15 of the 17 is the goal to stop and reverse soil degradation. And yeah, this is where my project fits in. So in Germany, we know that we lose a lot of soil to soil sealing. Here you have a graph from the Federal Statistic Office from 2022. And you can see that we are now by 54 hectares per day. It's like a decline since the last years. But even though we know we lose this much hectares per day, we don't know where we lose this and what is the soil quality that is lost because of the soil sealing. So the scope of the project I work in is the Soil.de project. And we are working on the derivation of soil functions and soil fertility to quantify and quantitative and qualitative assess soil loss in Germany. We therefore adapt and improve already existing soil functions and soil indicators to assess the yield capacity and the vulnerability of agricultural soils in Germany. I use different indicators: soil quality rating, biodiversity potential, filter buffer functions, resistance against erosion to water and wind, and runoff regulation function. To calculate all these indicators, I use different input data. So I use the soil data. It's the BIC 200. It's the highly resoluted soil data we have for the whole Germany that is consistent. Then I use land use data from the Copernicus. I use a digital elevation model, and I use temperature and precipitation data from the German weather forecast. So the journey on which we are today is: where is soil lost and what kind of soil are we losing in terms of soil quality? Yes. So the soil sealing data I'm using is called imperviousness layer. It's from the Copernicus land monitoring service. There are different reference years: 2006, 2009, 12, 15, and 18. And in between these reference years, we can calculate the classified changed layers in this 3-year period. So here you can see on the right, it's Berlin, and you can see the soil sealing. It's a 10 × 10 meter resolution since 2018, and before it was in 20 meter pixel size. And if you calculate the classified change, which is the data I'm working with here, you can see, for example, that we have the Berlin airport, probably you know this, it was in the news a lot, that was sealed from 2006 to 2009. We have a new cover here, which is the red color. So if I use this imperviousness layer data and I calculate it for all the 3-year intervals, for all federal states of Germany, except for the little ones, Hamburg, Bremen, and Berlin. They're left out here. And we can see there's a decrease, as we can see on the picture here. The more red, the later the year. 2006 to 2009 is the light color, and more intense is 2012 to 2015. But this trend, even though it correlates with the one I showed you previously from the Federal Statistic Office, that's already here again, we have an increase in hectare per day in 2015, 2018. But the Copernicus is like a little shy with this data. This is why I'm not showing it so intensely here, because they changed the satellite data. They use Sentinel-1 and Sentinel-2 now, and the resolution increased, and so they have like an increase in soil sealing that's not only real sealing, but also due to technical issues, and I need to resolve them. But as you can see, we have an increase in soil sealing when I look at satellite data. In total, we can see that Bavaria and Lower Saxony have the highest soil sealing in this 9 years, and we have a mean soil loss of 0.5 hectares, which is like 1 football field, to more than 3 hectares per day in Bavaria and Lower Saxony, which is around 5 football fields a day. Yeah, and these previous land uses that were sealed were fabric area, forest, heathland, industrial units, and agriculture. And I'm focusing on agriculture, and this is what I want to show you next. If we only look at agriculture, around 40% of the total soil loss occur on agricultural soil. So this is like a little different in the different federal states of Germany. So we have, as a mean, it's 15% for the smallest area, it's the Saarland, and 47% for Saxony, which is this federal state. Here I calculated the cumulative agricultural seal per municipality for the whole Germany for this 9 years from 2006 to 2015. And we have mean maximal soil losses of 1 to 3% per municipality. And you can see that we have a lot of soil sealing in the west of Lower Saxony, in the region of Frankfurt and Offenbach, and in the regions around Munich. And also, again, the Berlin-Brandenburg airport, which is caused 9% of soil sealing in the municipality. Which is like the peak in Germany ever. I want to take a closer look at the Lower Saxony, because this is where I'm from. Braunschweig is around here. And you can see that we have an increase until 2012, 2015, which is probably can be explained by the financial crisis, which happened in 2008, 2009, and maybe it was like the later cause, or like we see the cause of this financial crisis a little later. Less people buy new land, buy new houses. This is probably why we don't have a lot of soil sealing in 2012 until 2015. And what I want to show you is that for Lower Saxony, the share that is sealed due to infrastructure and building is a little bit more than 50% in the mean. But in total, it only makes up, like in the sum, less than 1%. So for the total area and also for the agriculture area, it's only 0.21%. So for the whole Germany, I calculated all these different soil indicators I already mentioned, and I clipped this with the soil loss on agricultural land use, so I can give a qualitative soil loss information. So I also wanted to briefly show you all these 7 indicators I calculated, and here you can see red colors mean it's a very low evaluation, a bad evaluated soil quality, and the greener, the more green, the better the soil was evaluated for this specific indicator. And because I'm talking about soil loss, I want to inverse the colors, because if we lose valuable, good quality soil, it's bad. So if you can see here that if I change the colors, if I inverse the colors, you see that we lose like about 75% of soil. So we lost it already, sorry. We lost 75% of soil that is either medium, moderate, or good quality for this soil functions I looked at. Yeah, if I, what was it? Was it for me? Oh, okay. I thought I was overtime. Okay, yeah. Yeah, for Lower Saxony, because I showed you all the 7 information, and you saw like it's a lot of information. I wanted to calculate one indicator between 1 and 100 to compare all the different indicators because they have different classes. And here you can see for Lower Saxony, for all the different times, 3-year time slots again, a mean for the different soil indicators, and you can see they're all in the red area or in the orange area. So we lost soil for the good or very high quality. And if we look at all federal states together, we can see that it's well, there are some differences between the federal states, but all in all, we can say that we are losing. We lost from 2006 to 2015 a lot of high quality agricultural soil due to infrastructure and building. To conclude, the satellite-based Copernicus land monitoring imperviousness layers showed an increase in soil loss in 2006, except for this period from 2012 to 2015. And as I said, in 2018, we have again an increase, but the technique is still developing, and this is why we need to work out what is real soil sealing and what is just a technical soil sealing. Yeah, nearly half of the sealed soils in Germany were previously under agricultural use, and 75% of these sealed soils had a medium good or very good evaluated soil functions and potentials. I also saw that there are clear regional differences between the different soil loss, between the different soil loss quantities in Germany, where we are more building, more loss of agricultural land. In the future, or my next steps are to explain these patterns I see in the German-wide map and look into regions where we have high rates of soil sealing, and to locate potential high-risk areas where we have high soil quality and potential high soil loss due to building, because you should look into the soil quality before you seal the soil of really valuable soil quality. Yeah, and I want to highlight the SoilDE map viewer, where you can look at the maps I already calculated. It's all in German, but we are working on an English version. Yeah, here's the URL, and yeah, I would like to thank you for your attention. Yeah, talk to me, ask me questions. Do we have a mic? Maybe.
Thank you for your presentation. I have a question. If you tried to calculate the same indicators using other platforms, also developed under the umbrella of the European Commission.
You mean other soil data?
Like land support developed by Italian group and other platforms available.
I only use the platforms I showed. I know there are different ones, and there are also different soil data, like the Lucas data.
Yeah, but no, it's not about the data. It's about the approach itself. You can implement on Germany calculation with different approach, and then compare and understand if it's in line or something different. I just encourage you to see land support project, which ended, and they're doing the same calculation, but for Italy. So you can against the satellites and other stuff. So it will be interesting to compare the results just for you.
Yeah, I will. I will ask you later because I land support. Yeah.
Thank you for your presentation. I'm Linda Maring from Deltaris. As you know, the soil sealing is quite an issue in Europe. Are the ministries also using this information or planning to use this information to make also policy against soil sealing?
I hope so. Well, I'm paid by the government to work on this. Well, we have a soil we want to secure soil, of course, in Germany as well. We have a law for it, and well, my project was specifically, well, it was by the government, so they have one indicator or multiple indicators that tell them what soil is lost and what soil should be, what parts of Germany should be saved. But I hope that the government is using my results. So that's the plan, at least. If they're happy, I don't know. We will see.
Okay, thank you very much.
We are out of time. Here we are.
The next presenter is Roland.
Yep. All right. Thank you. Let's see if I can find my presentation. Yep. Should I do something here? Yep. All right. All right, thank you, everyone. My name is Roland Eemhuis from the University of Leiden. Might seem a bit odd. I'm a geographer. I was trained here for my bachelor in human geography, but now I work in the Faculty of Archaeology. So I look at historical land use and past, well, societies that were agricultural, pastoral, and try to reconstruct how they functioned as a society and as an economy. So let's see if this works. Yeah. So in today's talks, and I assume tomorrow as well, we will be looking at a lot of pictures like this. So land degradation over pollution by nitrogen, massive landscape change, that is occurring now, and we need a lot of transitions. So most of the talks here will be talking about change. Something has to change, either small scale or pointer, large scale things, small scale things, anything. But let me make one thing very clear: in our economy, in our modern way of life, our culture of overproduction, so producing at carrying capacity or with the means of technological or chemical aids, over carrying capacity of the land is overproduction or hyperproduction. Our culture of overproduction is statistically the exception. If we look historically or anthropologically to every culture that is not our own, not our Western modern society, completely different. One of many examples is the CY, I hope I pronounced it well, of Bougainville, which is the Solomon Islands. They take pride in producing exactly the amount they need to survive, nothing more. That is completely strange to us. We always produce the maximum. That is current economic doctrine, to produce as maximum, as much as we can, or even looking at these pictures, over the top, producing over the top. So perhaps we need to revisit our state of overproduction, and a lot of things, a lot of solutions that we see here today and possibly tomorrow is taking it a step backwards. So less technology, less chemicals, more nature. But that comes with a shift that might be seen as an economic step backwards, which is perhaps not the case. It's also an adaptation to a new way of having an economy. That's not completely fixed on overproduction or hyperproduction. So, one very nice example I have for you today, in which the economy was geared to underproduction, so producing what you need and not more. But I will focus not on how that worked technically, but on how that worked as a society, because you need to change the society as a whole if you want to change your attitudes towards land use, land management, or as natives in Australia call it, land care. It's not land use, it's land care. If you provide for the soil will provide for you, which is what we need to do also. So try to see it not as a step backwards. We are not going to restore some past situation, but we do need to adjust our way of thinking to a new nature-based solution economy. So, big things. The earliest Middle Ages, also known as the Dark Ages, following the collapse of the Roman Empire. Roman Empire is, of course, one big feasting with surplus and overproduced agricultural products. Also, mechanized farming. They had machines for harvesting, pulled by donkeys. They had plows. They had a lot more technology than you would think, but I'll come back to that later. Of course, the Roman Empire fell, so this is a very quick overview of the early Middle Ages. Lots of people changed their settlement locations. They moved around Europe. Economies changed. Migrations and demographic decline followed, so less people. A collapse of the monetary system, rise of local warlords, in short, a complete chaos in economic sense. Until Charlemagne got emperor, so this is the 8th century, who restored economic agricultural production and increased under the aegis of church and aristocracy, who, well, made sure that the economy was functioning again. It was not at the hands of local warlords, no more chaos. It was nice, easy living there. Well, that's at least the picture that historians are building. Let me provide you with a new picture. Just to frame what I'm going to say about the evidence in land use later on. So we have in the earliest Middle Ages, so the 5th century, mainly the 5th and 6th century, directly after the retreat of the Roman Empire, we see these things. This is gold inlaid brooches with garnet. Garnet comes from India. So very high fashion, extremely difficult to produce because gold is a very soft material, cloisonné technique. We find these things, well, you would intuitively, you would think of aristocratic people or elite or whatever to have this. But if you look at the distribution of these garnet inlaid objects, they're everywhere. So might we come to the conclusion based on this that everyone is rich or there isn't a real aristocracy? Or both. Anyway, the archaeological evidence says life is not so bad, perhaps. Well, this is only one proxy. Remember, gold can be sourced in Europe. Garnet comes from India. So again, economic exchange network is already global in the 5th and 6th century. So elites everywhere. Then another proxy for the not so dark ages is the Oriental beads. This is a necklace with beads, and these beads can be found everywhere. Women are standard buried with beads around the neck, and these beads come from, well, you can see it, Egypt, mostly, but also Italy, the Far East, Middle East, etc. So the dark agents aren't so dark because everyone in the rural places is somehow connected to some global exchange network. So what am I going to do with this evidence to inspire this talk about, well, reconstructing our bon sauvage, our noble savage, so our middle-aged person, not middle-aged, but person from the Middle Ages, that is somehow very savage because there's no monetary economy, there is no transport networks, there's no formal state institutions. It's one big chaos, but still they have all these riches. From these riches and other archaeological evidence, I will present three archaeological pieces of evidence from Northwest Europe to provide attitudes on production. To determine attitudes in the early Middle Ages on production. So are they overproducing or underproducing? Attitudes on land use and attitudes on taste, which are all things that we need to change as well if we want to embrace nature-based solutions and stop thinking in terms of maximizing profit. So how can I reconstruct my noble savage, as it were? Settlement distribution in the Roman period. So this is the period of overproduction, mechanization in agriculture, a lot of surplus extraction by the state, has a clear bias towards, I hope you can see the colors. There's a difference between this pinky orange and this yellowish stuff that is in the Netherlands. So that's marginal land and more fertile land in agricultural terms. There is a bias towards, well, the more fertile areas, so the loess areas and the fluvial clays, because you see a high concentration of settlements here, 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 and here. Of course, this is excluding the villae, which are, anyone know what a villa is? No, I won't talk about it. At least this is the rural settlements in the Roman time, and if you look at rural settlements in the period 450 to 750, so directly after the Roman breakup, you can see that there is actually not really a bias towards marginal or fertile areas. You can see that here, the border is right here, and most of it is southwards in Wallonie. And here, most of it is actually in the Kempen or Belgium. So there's actually no bias towards in agricultural terms, there is no bias anymore towards some ecological productive zones. Remember that, that's the first thing. So what were they producing? This is only one site in Savy, Departement Aisne, in France. So what were they producing? At the beginning of the Roman era, a lot, different things. Then Roman period, mainly spelt. 5th century, so directly after the Roman period, a complete plethora of different crops. And then later on in the early Carolingian period, it declines a little bit and spelt is grown more. What I'm thinking is that they're diversifying in the early Middle Ages, diversifying crops. Now, why would they do that? Well, there's a parallel here in someone in anthropological literature made a list on the selection criteria of eating habits of non-modern people. So this is of African Bushmen, but it could be any other non-Western people. So in 4th place is ease of procurement, how easy it is to grow something. And third is abundance, mainly in natural resources. Second place as a selection criteria is assumed real or assumed nutritional value of the food. The first and foremost selection criteria for people to, get their food is taste, whether they like it or not. So people here were left to themselves. They diversified because they like different things. I don't believe that the people here only liked to eat spelt. So there was something going on between here and here that made them leave a monoculture and diversify their farming habits. And it might be one of these things, or all of them. Of course, we have no evidence of how these people thought, but this might be one very nice proxy for that. Keep it in mind. So third, the plow, the moldboard plow, as opposed to the ard. Ard is around since Neolithic times, so that's 5,000 years old, more or less. Moldboard plow is an invention made in late antiquity, so somewhere in the Roman period. Only somewhere here, we don't know exactly when it was conceived, but widespread use of the plow is assumed to be 4 centuries later. Now, the moldboard plow against the ard has immense advantages because you have to plow only half the time. It plows deeper, it has more weed suppression, it has a lot of things that make it a truly life-changing implement. If our agriculture is your daily business, you will want this one. Still, there is a gap of 4 centuries, unexplained spread of this life-changing implement. Why? Why don't they, these free people of Northern Gaul, don't use the plow? Given the advantage of the plow and the attested global exchange network, so it can't be that they just didn't know about the plow because they have at the same time beets from India. Why can't they get the technology from northern France? That makes no sense. So there has to be, well, going to my interpretations. First evidence was the bias towards biological zones, ecological zones. Means that there is no bias, there is an under-exploitation of the country. They are not exploiting the landscape efficiently or maximizing production. Otherwise, there would be a bias towards fertile zones in the early Middle Ages. It's not the case. So this is pointing towards, this is not proving, but this is making a good case for that the people are under-exploiting the country. Second is diversification of crops, possibly climate-induced because of the wettening and coldening of the climate. But bread wheat was anyway not really in taste. It was rye, spelt, oats, and barley, which are all more or less good producing in cold and wet climatic conditions. So. But nonetheless, they are still away from monoculture. And third, the plow, a conscious underproduction after a period of overproduction. Yeah, this is only one slide. And this is the most important one. So they are consciously underproducing. They are having a global exchange network that goes all the way towards India. But they somehow don't feel it necessary to adopt the new farming techniques. This cannot be something else than a conscious culture of underproduction. Remember the CY of the Solomon Islands, taking pride in producing as much as you need and not more. So, to come to my conclusions. First of all, the availability of technology is a prerequisite, of course, but hardly ever a determinant in socio-ecological transitions. You need a new technology, but that doesn't mean that it fits the culture that might benefit from it. Second, the use of technology is determined by the prevailing cultural system. If a new technology just doesn't fit with the belief system or value system of a society, it won't be used. However life-changing or good for the planet it is. And then, actually, a thought, conclusions and thoughts. A discorrespondence between land use and social organization. What we have now, we have land use that doesn't seem to fit our social organization anymore. And overproduction are possibly two sides of the same coin. So we are overproducing, but that might just well be, you have to get, maximization of production is a matter of value. It's not natural to be overproducing. It is, we are the statistical exception in that as a society. It is also culturally determined. And last one, to value taste as being important, put taste as at number 1 of selection criteria, is also culturally determined because we don't seem to do that anymore. At least not if we go to the coffee machine here, that doesn't taste at all like coffee. And yet everyone's going there. Anyway, these are my thoughts and conclusions. Hopefully at a grand economic societal level might help change our way of dealing with land use, and this planet. Yep. 21 minutes.
21 minutes. You have only 15.
Oh, sorry. There was no one to raise a hand for applause.
No, it was her job.
Thank you very much. And now
we go to try if we can have the
online presentation.
Mm-hmm. Well, no, sorry,
not this time.
Daphne, can you try to share your screen if you are there? There's this.
Hi.
Yes.
Can you hear me?
Yes, I can hear you.
I think, okay, I will try to share it then.
No, somewhere else. Oh, okay.
Is it visible? Should I also turn my camera on?
Yes, you can probably do that, yes.
Yeah.
Yes. It's a miracle.
It's a miracle?
It's really a miracle.
That is working.
Now the only thing I need to do is that I need to see how I can get this on our screen in a proper way.
Like this?
No, you're doing fine. There is nothing that you can do more.
Okay.
Okay. We're going to do quick and dirty.
Sorry, can you repeat that?
Oh. So just start.
Okay, so I can start now.
Yes.
Okay, so hi, and thank you for the opportunity to present a part of my master's thesis that I'm doing in Wageningen University, and it's called How Can Different Decision-Making Criteria Shape Mulching Techniques in Burned Areas? So wildfires are an even more frequent and severe phenomenon worldwide, and they undeniably have devastating effects on nature and society. I'm sorry, I can't hear myself. It's a bit confusing. So some of these effects on hydrological properties of a system, and that is because we have vegetation loss and loss of cover and loss of roots and organic matter. And because of the high temperatures that are developing when we have a wildfire, there are changes in soil's physical and chemical properties. Therefore, we have very high rates of erosions and some flood phenomena related to wildfires. So we have ashes that are transported downslope, and ashes are severe contaminants when they exist in high proportions, and oxidation of organic carbon to the atmosphere. So measures to minimize post-fire soil erosion and its offsite effects, or only its offsite effects, if we trap sediment downslope before reaching a specific target, are called emergency stabilization measures. One of them is mulching, and I have focused on this specific measure for my research. So mulching has the unique characteristic of preventing the soil from eroding on site, and it has been proven that it's very effective in terms of sediment and water runoff control. Here we see an example of spraying mulch in the US. But there are some difficulties arising in the implementation of this measure. That is because there are multiple tasks to be completed by emergency response teams in order to design these measures, and all that has to be done in a very short time frame. To be specific, these treatments have to be placed before the first damaging rain in order to be efficient. And there are many stakeholders involved in this, especially if land is not public. So there are many arising logistic issues that delay application, and we have stakeholders that are skeptical about the measure's effectivity, profitability, importance, etc. And that brings me to our research objective. That is, how can modeling support decision-making by being part of prioritization protocols? And what are the differences in the resulting areas when we model with different priorities in mind? So the case study is in southern Portugal, is West Algarve, and here we see in this shape the 3 fire events that happened in 2003 and damaged approximately 65,000 hectares. In these pink areas that you see here is areas that are burned at high severity or moderate high severity, and they are 40,000 hectares. So we have very high intensity fires, and many major water reservoirs in this area were severely affected for years after the fire. So in order to answer those questions that I mentioned, we designed 3 different scenarios with different priorities and focus, so to say. So the first scenario focuses on the protection of the soil from erosion, regardless of offsite parameters. To do that, we use the revised universal soil loss equation. That's pretty straightforward. It's the multiplication of these factors. The result of this model is an estimated yearly erosion rate risk. And we chose RUSLE because of its simplicity. It has been tested multiple times in Europe and in the Iberian Peninsula. And it has shown that it operates well at large spatial scales. For the second scenario, we focus on the protection of freshwater bodies from sedimentation. And on the third, for the protection of road infrastructure. So to do that, we follow exactly the same process with different targets. This process has as an output the multiplication of these 2 factors here, the RUSLE result, and the sediment delivery ratio. That is a number from 0 to 1. And it is a proportion of the eroded sediment in each area that would reach a specific target. It has a high risk to reach this target. This number, sediment delivery ratio, is a function of sediment connectivity index that is qualitative, and it is used to compare the source and sink connection degrees of different points within a catchment. So this is the result from the model RUSLE. As we can see, the vast majority of the area, 95%, is belonging in the first class of erosion, that's less than 1 ton per hectare per year, and the minority belongs to the other classes. However, we can see that although it is a minority, these are significantly large areas that have erosion that can be considered very high. And those are the results for the second and for the third scenario. When we target the streams, we can see we have higher erosion than when we target the roads. Namely, we have 96% of the area belonging to the first class, while when we target the roads, we have 98% of the area belonging in the first class. That is, yes, significantly less erosion, and that can be interpreted in many different ways. For example, the streams, rivers, channels, etc. are much more present in the area rather than the important regional roads that are taken under account for this study. So in order to target specific areas for prioritization, we have to choose specific thresholds. And that is not a straightforward process. So we chose 2 thresholds, 1 and 10, for each scenario. For example, for the first scenario and the first threshold, where all the areas that have more than 1 ton per hectare per year of predicted erosion risk are chosen, and so on. So this is the comparison. For visual purposes, we choose a specific part of the case study area. And you can see that the red areas that show the more strict scenario, let's say, that more than 10 sediment export for the case of the second and the third scenario are barely visible and mainly present here in this mountainous burned area. Of course, the products of the second and the third prioritization scenario are included in the first, because the first is the net erosion. What is also interesting to say is that these scenarios are synergistic or complementary, let's say, to up to one specific degree. We see in these Venn diagrams how the scenarios overlap. For example, this circle here depicts the areas that are very high net soil erosion, more than 10 tons per hectare per year for the first year after the fire, and they do not exactly overlap with this scenario that is targeting the water and the river and the reservoir. Sorry. So there are some areas with very high erosion that do not affect the streams this much, and the other way around. And here we can see it even more visibly. There are many areas of very high erosion that are not affecting significantly the roads, and the other way around. There are some areas that are affecting the roads, but do not have a high net soil erosion. And that can be explained also by the nature of the roads, let's say, that roads are built whenever humans build them, while the water exists already where the natural forces bring the sediment and the water. And we can see here in these very small circles that for the water 10 and road 10 scenario, there's only around 30% of overlap. And that brings me to the discussion. There are, of course, some weaknesses in this methodology. For example, there are many site-specific and event-specific factors that are very complex and difficult to consider in a large scale and short time frame. Also, the databases are still incomplete or are in a very low resolution for such a project, and the erosion thresholds are arbitrary. A final comment is that when measures are implemented or designed to be implemented in an area, the connectivity levels downslope of this area are affected. That is how the sediment connectivity model is working. So when we design some, for example, mulching application in an area upslope of a specific point, then the point's sediment connectivity levels are changing, and we have to rerun the model in order to find out what is happening downslope of our proposed measures. Sorry. Yes. And the strengths of this methodology is that models can facilitate the communication between different stakeholders, especially if they're easy to illustrate and straightforward. And they can make the prioritization process faster and more efficient. That is already happening, of course. In many cases, the emergency response teams are using modeling, and they can increase the preparedness by pointing the targets even before a fire event. So that is presentation. Thank you very much for your attention.
Thank you very much. If anyone wants to ask some quick question. Okay, so thank you very much, Daphne. Next presentation will be Veronica.
No, I'm not Vero. So
Okay.
Yeah.
Zero attendance. We are here. No, no.